Okay, so I'm going to make a new video for finding the forms of a line for you guys. Um, I don't think this is a particularly tough topic, and yet if you just haven't done it, it could be one of those spots that might trip you up a little bit. So um, let's see what we can do with that. So the first thing to be aware of is there are three forms of a line that we are going to emphasize in here. And so the first form that I think most of you guys are probably familiar with is called slope-intercept form. And I do think most know that well. And that's the good old fashioned, when you say something like -3/5 x plus 2, you're going to go find your y-intercept at 2 and you're going to drop 3 and you're going to run 5, and it's a great form of a line because it allows you to graph really, really simply because you just need a starting point on the y-axis and then you just go for it. Okay, that's a great form of a line. There's an alternative form of a line that is, again, this is slope intercept. There's an alternative form of a line that looks like this right here, and it's called point slope. And this is actually my favorite kind of a line myself. And it requires you to know any random point. So rather than knowing a value on the y-axis, you could literally just pick some rando point over here, called it x1, y1, and it allows you to rise and run. And see, if you rise delta y and you run delta x, you're going to get a second point. And of course, we should know that anytime you have 2 points, you're going to have a line. Now, that really is hard for people, but one thing that is kind of convenient is that if you divided both sides by this portion in parentheses right here, and I'm doing that real quick, I'm just going to divide by x minus x1, those would cancel. And you're going to notice this little statement that m looks y minus y over x minus x, which is kind of our slope formula. So it sort of makes sense. The only difference is in the slope formula, we usually have a 2 right here and a 2 right here, which would specify 2 distinct points, whereas we actually don't just want 2 points. We want every point that exists on that line, okay? So form 1, slope intercept, is the one you first were taught. Point slope, a little bit more advanced. And then the last one is ax plus by equals c. And this is called standard. And standard is actually the one that is favored by a lot of engineers and an awful lot of mathematicians. Because A, B, and C aren't fractions. We would do something to ensure that they are not fractions. So A, B, and C are integers. So numbers like -2, +5, 1, etc. And A is always positive. Those are our stipulations. It makes it really easy to work with. So without doing a whole lot with this, I kind of wanted to first off talk about how do you go between forms. So very frequently, you'll have a problem like this, -7/8 x plus 2. That's in slope-intercept form. It's the one you're comfortable with. And let's say somebody says, I want to go to standard. Now, again, not particularly difficult because the first thing it says is don't have any fractions. So, of course, if I could multiply everything through here by 8, this would give me 8y equals -7x plus 16. Be careful that you hit every single piece by that number. But of course, standard should look like ax plus by equals c. So I need this x to be on the other side. So if I added 7x to both sides, 7x plus 8y equals 16, we should be good. Now, one thing that I would like to emphasize to you guys is that when you are learning how to do mathematics, it's a really good idea to go ahead and just check and make sure you have done okay. So I'm sharing you over here with a Desmos screen, and I had y equals -7/8 x plus 2. So I've got this nice little green line, and I want to make sure that I did this other line correct, and it was 7x plus 8y equals 16. And it takes so little time just to see that they in fact land on top of each other. So I know that I did actually a good job. Okay, so that's the first one. Another one. Let's say that we go ahead and say I want to go between point slope, my favorite, and slope intercept. So let's see. So somebody says, hey, I've got y minus 4 equals 2/5 of x minus 7, and I want to go to slope intercept. Now, I wanted to be very, very clear. I could graph this problem absolutely fantastic from here. I'd find the coordinate 7, 4. Notice that it's x, y. And I'd go up 2 and I'd go over 5. I'd get another point. So I can graph it really, really nice and easy from this form. But if we wanted the other form, which frequently we do, the first thing you do to get rid of point slope is distribute the slope through. So 2/5 times x is 2/5 x, and 2/5 times 7 is negative 14/5. Very simple, because remember, this 7 is really 7 over 1. So 2 times 7 and 5 times 1. Well, of course, the only thing left to do is add 4 to both sides. But instead of adding 4, I'm going to add 4 in the idea of 20/5, because 20 divided by 5 is 4, and I needed a common denominator. And so I end up with this 2/5 x, remember those canceled out. And if I took negative 14/5 plus 20/5, I got 6/5. Now, again, it would be pretty easy for me to check this answer and make sure that I did okay in Desmos, right? So let's just change this up. And I had my first equation was y minus 4 equals, let's see, I had 2/5 x, and looks like a minus 7. So there is my first line. All right, and hopefully I did okay on my other line. Y equals 2/5 x. Notice the same slope in both cases, plus 6/5. And let's see how we did. I'll turn that on, and they landed on top of each other. Very quick, easy confirmation that I did okay. Now, this problem was actually very easy to do in point slope form, because notice my coordinate 4, 7. I'm going to go ahead and put 4, 7 on my graph and label it, 7, 4. I did it backwards, didn't I? 7, 4 on my graph. There it is, nice and pretty. Let me turn these labels off for a moment. So I got my point, and then if I rose 2 and I ran 5, of course, if I rise 2 and run 5, I would hit 12 and 6 if I did it right. And let's see, yeah, we did great. Okay, nice. Okay, so the last thing that I wanted to mention to you guys is the last piece. And this is the part that I wanted to really do the video for, is let's say somebody handed me 2 points, -8, 2, and 7, 5. I had those points already on Desmos, you might have noticed when we started this question. And I'm asked to find the equation of the line and all of the values possible. Well, that's kind of a longer problem, but we can get there fairly quickly, because the first thing I want to know is what is my slope. And I told you slope is best found through rise over run, or delta y over delta x. So you're going to notice that my y's from 2 to 5 went up by 3. And my x's from -8 to positive 17, 7 went up by 15. So it looks like I've got a nice easy slope of 1, 5. So finding the slope was pretty straightforward and simple. Now, I'd already told you I really like point slope, so that's where I'm going to start. And it doesn't matter which value I pick. I guess I'll pick this one. I'm going to go y minus the y value. Remember, that's the y value. I've got x minus the x value. And then in front of this number right here always goes the slope. And I should write it as y minus your y value x minus your x value, and your slope goes right here. And you could pick either point and you'll get the same thing. So we already have our point slope form. And a moment ago, I went through how could I turn this into slope intercept? Well, again, the first thing I'm going to do is distribute. And the second thing I'm going to do is I'm going to add that 5 to both sides. But instead of thinking about this as a 5, I'm going to think about this as a 25 fifths. Now, I realize that that is not a super, super kind value, but that's okay. It's a perfectly fine value. And then the last thing is to get, so here's slope intercept. We got it. Slope intercept. And last but not least, if we wanted to go to standard, we're not allowed any fractions. So I'm going to multiply everybody by 5. That's 1x plus 18. We're getting close, but we should have all the x's and y's on the same side together. So I'm going to move this x to the other side. And last but not least, the little rule says that you are never, ever, ever allowed that x value to be negative. So I'm going to multiply by -1. And I've got x minus 5y equals -18. Now, it shouldn't be a terribly difficult thing to do, but we've done a fair bit of math. So again, really, really encouraging you to go back and take a look and make sure that you have not made any mistakes. So I already have this problem ready to go in Desmos. I have my two coordinates, -8, 2, and 7, 5. Let's see where, there they are. Let's label those things. Nice. And so I have my three forms. My first form was y minus 5 equals, let's see, it was 1/5 and x minus 7. And if I've done this right, it should go right through my 2 points, and it looks really nice and pretty. Then I'm going to try that again, and I'm going to try y equals 1/5 x, x plus 18 fifths. And if I've done it right, it should land right on top of the other. Notice the line turned green. They have the same exact equation. So the blue one and the green one match. And last but not least, x minus 5y is 18. Oh, that's wrong. But I forgot there was a negative on it, huh? So I'll put a negative on that and boom, we got it. Now the thing is you don't necessarily have Desmos when you're taking a test. So one last little thing, and it has to do with the fact that we've done a fair bit of work. I would encourage you, see, all of this information that I did was predicated on using the value 7.5, right? And I didn't really use the -8.2 other than finding the slope. So what I would encourage you to do is this last thing that we did, let's just plug it in and see what happens. This says if I took my x, which is -8, and I took a -5 times my y, and -5 times +2 is -10, this claims that my answer should be -18, which it clearly is. So I know that my original one went through 7.5 because that's how I forced it to go. And my other one goes through my other coordinate, -8, 2. So I'm pretty confident I did well. But of course, I could also plug in -8 for x. I could plug in 7 for x, which would be 7. And -5 times +5 is also -18. So we could actually take an extra second and plug in both points. And you know what? 2 points always make a line. So if both points work, we had to have nailed that question. Please don't miss that one on the test. All right, I'll see you back in class. Have a good one.